Good day to all my listeners home and abroad. Welcoming you back to today's chemistry class where we shall be talking about isobars. For your revision, in the previous class we talked about isotopes and isotopy. Today we are looking at isobars and how they are different from isotopes. Isobars are elements having the same mass number, that is, atomic mass, but different atomic number. There's different atomic number. As we have it on the board, we have iron 58 and nickel 58. So the mass number for iron is 58. The atomic number for iron is 26. That means in iron we have 26 proton. We have 26 electrons, and the number of neutrons is going to be the difference between 58 and 26. So subtract 26 from 58. That will give us the total number of a neutron, and that's going to be 32. So let's look at nickel. Nickel also has 58 as mass number, but its own atomic number is 28. So what we call isobars, they have the same mass number but different atomic number. So that means proton number in nickel is 28. The number of electrons is also 28. So subtract 28 from 58. That gives us 30. So the number of neutrons in nickel is 30. This is what we call isobar. We shall consider another example to help your comprehension. Stay tuned. mass spectrometer. Mass spectrometer is the apparatus for determining masses of isotopes and molecules. It can differentiate between isotopes of the same element. It has 6 important parts. So what we call mass spectrometer, that's the device or instrument that is used for comparing masses of elements, isotopes and molecules. It has 6 important parts, which we shall discuss in the next slide. So on the board, we have the diagrammatical illustration of the mass spectrometer. As it has been said earlier that it has 6 parts. The first part is the vaporization chamber. The second part is the ionization chamber. The third part is the accelerating electric field. The fourth part is the deflecting magnetic field. The fifth part is the ion detector. And the sixth part is the recorder. That's a graph that you can see, where you have on the vertical axis the relative abundance, and then on the horizontal axis you have the mass to electron ratio. So this is the diagrammatical illustration of mass spectrometer. So in the next slide you shall see the function of each of the parts of the mass spectrometer. So we are looking at the functions of the parts of the mass spectrometer. The first part is the vaporization chamber, where the sample to determine its mass is put. So the function of the vaporization chamber is to vaporize and change the element or the compound to be analyzed into gaseous form. Then the second part is the ionization chamber. This is where the vaporized sample is converted from atom to ion, or from molecules to ion. Don't forget that ion is formed when electron is either lost or gained. When electron is lost, positive ion will be formed. And when electron is gained, negative ion will be formed. When electron is lost, the positive ion that is formed is called cation. But when electron is gained, the negative ion that is formed is called anion. So in the ionization chamber, it ionizes atoms or molecules of the vaporized sample by knocking off electrons from them to form positive ions, which means electrons are being lost, and that is why positive ions are formed when the electrons are being knocked off from the atoms and molecules. The accelerating electric field. It accelerates the positive ion that is formed from the ionization chamber at a very high speed and moves them towards the magnetic field. It moves them towards the magnetic field for deflection. So now we talk about the deflecting magnetic field. It deflects the positive ions along a circular path. And you must take note that the lighter the ions, that is, the lighter the positive ion, the greater will be the deflection in the magnetic field. and the smaller will be the radius of the circular part. You should also note that for another greater deflection, the higher the charge of the positive ions, the greater the deflection. So two things affect the deflection of the ions in the magnetic field. That means the weight of the ion, which we can regard as mass. The lighter the ion, the greater the deflection. The second one is the charge. The higher the charge, the greater the deflection. The higher the charge, the greater the deflection. So let's take note of that. Smaller mass encourages greater deflection, while higher charge, as in greater charge, encourages greater deflection. The ion detector, that is the fifth part. The ion detector is the fifth part, while the recorder is the sixth part. The ion detector, it converts the signal of different mass over electron ratio received into electric current. The magnitude of the current is proportional to the number of ions. That means it is directly proportional, which means the higher the number of ions, the greater will be the magnitude of the current, and vice versa. So the lower the number of ions detected, the lower will be the magnitude, that is the size or quantity of the current. The recorder, it traces out the ion detected in the ion detector by recording the mass to electron ratio of the ions and their corresponding intensity. So it is the recorder that brings it out in form of a graphical chart. So we shall look at how to read the recorder in the next slide. Stay tuned. On the board we have the recorder chart for neon, which is an inert element. So we have the relative abundance at the vertical side, and we have the mass to electron ratio at the horizontal side. So you are asked to determine the relative atomic mass of neon. The relative atomic mass of neon. So to determine that, there is a solution. The relative atomic mass of neon, that will be 114 times 20 plus 21 times 0.2 plus 22 times 11.2 all over 114 plus 0.2 plus 11.2. So press your calculator and let's see what shall give us. So by our calculator, 114 multiplied by 20 will give us 2,280, 2,280. 21 times 0.2 will give 4.2. 22 times 11.2 give 246.4. The addition of the denominator give 125.4. If you divide the numerator by the denominator, you will arrive at 20.18 as the relative atomic mass of neon. Relative atomic mass of neon. As you know, neon is atomic number 10 on the periodic table, and it has an approximation 20 as the relative atomic mass. We shall consider one last example before we bring the section to a close. On the board is given the recorder for PB, which is lead. So, you have the relative abundance height. You are given the relative atomic mass of lead to be 207.24. So you have to find the relative abundance at 208. Solution to that, relative atomic mass, that will be 204 times 1.5 plus 206 times 23.8 plus 207 times 22.6 plus 208 times x all over 1.5 plus 23 plus 8 plus 22.6 plus x. So let's press our calculator and see what we are going to get. So as we have it on the board by calculator, we have those values: 306 plus 4,902.8 plus 4,678.2 plus 208x all over 47.9 plus x. So what we are going to do next is to substitute our relative atomic mass with 207.24. Let's see what we arrive at. So by our calculator and cross multiplying, you will see that you cross multiply, so this multiply this. So we have the analysis on the board. Ensure you press your calculator to ascertain the correctness of those figures. So then you collect like times here. You bring this to this side and this to this side. You want to have x to this side and this to this side. So you subtract. After your subtraction, you arrive at 39.79 equals 0.76x. Then you make your x the subject of formula by dividing this side by the coefficient of x, 0.76. We arrive at 52.355. Approximately 52.4. So your x is 52.4. So like come your way some other time. Keep studying, keep learning. Bye.